is to find the shortest distance between 2 points on a graph. And we're going to be given two coordinates, two ordered pairs, and we're going to use both a picture, the graph, and the Pythagorean theorem to show the distance, or to determine the distance between those 2 points. Here we go in our first example. Here you see the 2 points are 4, 3 and 10, 9. You see that I have both of these 2 points labeled with a smiley face on the graph here. And so what we're going to do is determine the distance between these 2 points. The point 4, 3 and the point 10, 9. I'm going to show it visually using a picture, but at the same time, I'm also going to show it to you using the Pythagorean theorem. So ultimately what we need to do is find the area of the square from this hypotenuse. In order to do that, we need a right triangle. So I'm going to draw the right triangle. There it is. In order to use Pythagorean theorem, we need to know the length of the legs. Well, we can take a graph and we could just count them, but I'm going to think of it a little bit differently here. Right now, I am on block 4. I'm going to walk all the way over to block 10. So how many blocks did I walk total? 6. Another way of getting that would be to go take 10 minus 4. That's going to give me my horizontal distance. And so the area of that square is 36. What I'm really doing is taking my x-coordinates and subtracting them. That gives us the horizontal distance. 6 squared. Let's do the same thing vertically. Here I am right here, and I am, let's call it at a temperature of 3, and we go all the way up to 9 degrees. Well, how much did the temperature increase? From here to here is 6 degrees. 9 minus 3, which is 6. And so the area of that square is also 36. From here, I can use Pythagorean theorem. Area of this hypotenuse square is 72. And so the actual length of that hypotenuse is the square root of 72, which is approximately 7.4, 7.5, somewhere in there. So you see how we can still do this visually, but you can also see how I am using the ordered pairs over here in the Pythagorean theorem. Second problem. We have 2 points, -5, -6. And we have the point 7, 4. And what we're doing is trying to find the distance between these 2 points. If I build my right triangle, this is what it looks like here. I'm starting here at -5, my x-coordinate is -5, and I'm going all the way over to 7, right here. Well, how far did I walk? How many blocks did I walk? From -5 all the way to 7 is 12. Here's a computational way of doing this. I take my x-coordinates and subtract them. So that leg is 12, and therefore the area is 144. The vertical distance, right here, let's consider the temperature of 6 degrees below 0. And it climbs all the way to 4 above 0. Well, how many degrees did it climb? I can take my y coordinates and subtract them. Negative 6 minus 4. If I square that, when I subtract, I get negative 10. When I square it, I get 100. So from here to here is 10. The area of the square is 100. And so furthermore, my hypotenuse square is 244. The exact value of my hypotenuse then is the square root of 244. And the approximate value would be the square root of 244, which is 15.6. And you can use a calculator for that. So those are two very quick examples. In words, here's what we're really doing. We're starting with Pythagorean theorem. And I need to find the horizontal distance, the horizontal length. I draw a quick little picture. Here's my hypotenuse. I need to find this horizontal distance so that I can get the square. How can I do that? I can subtract my two x coordinates. I also need the vertical distance right here so that I can get my area of the square of the vertical flag. When I add these two together, then I'm going to have my hypotenuse square. So it's really the horizontal distance squared plus the vertical distance squared giving me my hypotenuse square. Now how do I get my horizontal distance? I can subtract my x coordinates right here. To get my vertical distance, I can subtract my y coordinates. Think about a thermometer there. Once I have those distances, I square them, and again I get my hypotenuse square. Last thing, then, is you add them together to give us this guy, the area here. But we don't want the area, we need the side length. So to go from area to side length, we square root the sum of those two squares. And this right here is actually what we call the Pythagorean, not the Pythagorean theorem, but the distance formula. And you'll recognize that distance formula from your MCA packet, the MCA formula sheet. So really, the distance formula is coming from Pythagorean theorem. Now, if you're not comfortable using the distance formula, that's totally fine because you just revert back to this Pythagorean theorem. I'm going to have you try a problem on your own, pause it, and then we'll see if you come up with an answer. When you do this, I would like you to try to do it with just the equation, but if you need to draw a picture, certainly draw a very, very quick little sketch to help yourself out. All right, let's see how we did here. See if you got this correct. I'm going to just quickly give myself a visual for it. Here's the point, -6, -2. And then the point 4, 6. So what we're doing is we're trying to find the length of the segment between those 2 points. If I use my Pythagorean theorem, I'm going to write it down first. A squared plus b squared equals c squared. To find my horizontal distance, I subtract my x coordinates. 4 minus -6 and square. 10 squared. So from here to here is 10. The square is 100. To get my vertical distance, I need to take my y coordinates and subtract them. And so the distance from here to here is 8, and the area of that square is 64. When I add them together, 100 plus 64 equals 164. 164 represents the area of the hypotenuse square. And so if the area of the hypotenuse square is 164, its side length is this. And furthermore, the approximate value is 12.8. And that is using Pythagorean theorem to find the length of a segment given two ordered pairs.